Hi guys, this is a short video just to answer a question which was, that I received, why is 0 factorial 1? And that's an interesting question. It's definitely counterintuitive. Let's take a look at why though, okay? First, when we define n factorial as n times n minus 1 and so on, all the way down to 1, you have to realize we're defining n factorial algorithmically. In other words, we're defining it in terms of a course of actions that you can embark upon to achieve what n factorial ought to be. But that's different. That's not necessarily a good way to define things. What I want to do is offer an alternative definition right now that I think might answer the question. Let's think about n factorial as being the number of choices that you have in placing n objects in n locations. And we'll see in a minute why this is so functional, and actually a better way to define n factorial sometimes, and why it's so useful, okay? What makes factorial so useful. I want to point out that there are more abstract ways of defining n factorial. And there's even a continuous function called the gamma function that is closely related to this, but works for all real numbers. In other words, it's not bound or tied just to the integers like n factorial is. So we can actually be much more abstract with this if we wanted to head in that direction. But right now, we don't need to, especially just to answer this question, why is 0 factorial 1? So let's take a closer look at that. And I'm going to use an example. Let's use something kind of concrete. I want you to imagine that you're attending a wedding, okay, as if a wedding was possible right now. It's an illegal wedding. It's a gathering of more than 10 people. We're flouting the law. We're going to go to this wedding. And so you're an usher, and you need to seat 4 people in 4 chairs. Okay. How many different ways can you do that? These are our 4 chairs. I'm just going to make spaces right here. Those are chairs, believe it or not. So we're trying to figure out how many different ways do we have to be able to seat those 4 people in those 4 chairs. And you know what I'm going to do? I'm just going to start expressing the amount of choices we have per chair. We're going to seat the first person in the first chair. How many choices do we have? Well, we have 4 people for that first chair. How many people do we have for the second chair? We actually only have 3 people now, don't we? Because whichever one of those 4 we chose for the first chair has now been chosen. So we only have 3 people left available to occupy that third chair. Now we have 2 people seated. So for the third chair, we're left only with 2. And then finally, after we've seated 3 of the 4 people in the first 3 chairs, we only have 1 left. And that's the guy that gets the last chair. It's almost like musical chairs, isn't it? Now, in terms of finding out how many different ways can we go about doing that, we have to multiply them together. Now, you guys already see the connection. It's a factorial expression, isn't it? It's 4 times 4 minus 1 times 4 minus 2 all the way down to 1, which is just like we've been defining the factorial procedure. This is, what do we have? That's 12. That's 24, I guess, doing it in my head. Okay. Just to finish the calculation. But the point is, how many degrees of freedom do we have? How many different choices do we have in terms of how we seat those people? Now we can take it and shorten it. And if you're thinking ahead as far as how I'm doing this and where we're going, I think that's great. That's fine. But let's do it a little bit carefully. Now we're down to 2 people for 2 chairs. We would have 2 times 1. That's 2 choices. How many choices do we have when it's 1 person and 1 chair? Only a mathematician could ask a question that silly, right? But if we have 1 chair and 1 person, we have one choice. Okay, so here's the big payoff. And Amna, this is for you. If I have zero chairs and 0 people, how many choices do I have? And that's the key concept. How many choices do I have to seat 0 objects in 0 locations? Well, you still have one choice. And that is the choice to not seat anything in any location. It's still a choice. You still have a course of action, which is really what we're talking about. You have the option not to do anything with anything. And that's why, actually, let's put it this way real carefully. That's the first way to think of, and the most important, I think, the first and most important way to think of why 0 factorial is still 1. Hope that answers your question well, and keep the questions coming, guys. Thanks.